Okay, I hope the graphing went well for you, but I think maybe if we do more and more graphing, you're going to find that some problems exist when it comes to solving by graphing. There are times that there can be solutions to systems of equations that are fractions or that are decimals, which would be really difficult to determine by just graphing, to figure out where that exact point is that two lines are going to intersect. So there are other ways to solve a system rather than just graphing. Plus, not all of you are huge fans of graphing. So the second way that we can solve a system of equations is by what we call substitution. And in order to substitute, the word substitute means, if you think about it, it means to replace something. If you substitute a player in a game, then you are taking one player and putting another player in that place. If you substitute something into a recipe, then you are taking something and plugging it in the place of something else. So to substitute means to replace with something else. So when I look at this system of equations, I see that I have one where y is by itself. And if it says y is equal to 6x plus 7. So this 6x plus 7 is the same as the y, so I can substitute into the second equation. I can substitute this quantity into the equation and replace the y. Since they're equal to each other, I can substitute one for the other. So I'm going to take this 6x plus 7 and I'm going to substitute it into the bottom equation for y. So this is what I'll have. I'll have 3x minus 8, and instead of the y, I'm going to substitute 6x plus 7. And then it still equals 4. Okay, so all I've done is I've replaced this y. Everything else has stayed the same, but I've replaced this y with what y is equal to. I've substituted. And now I can solve that algebraically. I would have to distribute here. So I would say 3x minus 48x minus 56 equals 4. I can combine like terms that I have here. These are like each other. They're on the same side of the equation. So 3 minus 48 is a negative 45x minus 56 equals 4. I'm going to bring this same equation up here so we have a little bit more room to work. Negative 45x minus 56 equals 4. Okay, I'm going to add 56 to both sides. So I'd have a negative 45x is equal to 60. And then when I divide by the negative 45, I would get x equals a negative. Now 60 divided by 45, it's not going to go in there evenly. You could use your calculator. Be careful if you get a repeating decimal, because you're going to probably want to leave it as a fraction then to get the exact value. I know that 15 will go into both of these. So if I divide the numerator by 15, it goes in there 4 times, and the denominator, it goes in there 3 times. So I'm going to use a negative 4/3. I would not want to use a decimal here, because I would have to round the decimal, which is going to affect my y value that I get. That's going to make that off a little bit too. So leave and work with the fractions. Okay? Now that I've found x, I've got to plug it in and figure out y. Remember, in the graphing, we had an ordered pair for an answer. We had an x value and a y value. We have now calculated our x value. We've got to go back and plug it in to find our y value. And the easiest place to plug in is up here where it says y equals. So I'm going to come over here and I'm going to say y equals 6 times my x value. Well, my x value was a negative 4/3 plus 7. Okay, I'm going to do the math here. So y equals, this is 6 over 1. I don't know why I put a 6 there. This is 6 over 1. So when you multiply straight across, you're going to get negative 24 over 3. Negative 24 over 3 is a negative 8 plus 7. So y equals a negative 1. So we put our answer back together as an ordered pair. We always put x first, and we put our y value second. Now this is a great example of why graphing would be hard to do, because on a graph, that's going to be hard to estimate where negative 4/3 is on the graph. Okay, so this is a great example of why substitution is necessary. But if I were to substitute that point into the top equation, it's going to be true. If I were to take that same x and y value and substitute into the bottom equation, it would be true as well. Okay, that's how substitution works. Let's try another one. Okay, so I'm going to write down. Okay, I've got 2x plus 3y equals 7. Negative 7, sorry. And I've got a y equals 2x minus 1. Now, when you're using substitution, you always want to check out and try to see if you have a variable that's by itself. It's not always going to be the x variable, or I'm sorry, in this case, the y variable. Y is not going to be the one that's always by itself. It can be x. But we need to have one variable by itself so that we can substitute into the other equation. And since in this case y is equal to this 2x minus 1, I can take this and I can substitute it into the top equation. So I would write down 2x plus 3. Instead of the y, I'm going to substitute what y is equal to, 2x minus 1, and it equals a negative 7. Okay, now I'm going to go ahead and solve that. So I'm going to want to distribute here. I would get 2x plus 6x minus 3 equals a negative 7. Okay, 2x plus 6x. They're on the same side of the equation. They can be combined. That's a total of 8x. I'm going to add 3 to both sides. So 8x equals negative 4. If I divide by 8, now don't get in a hurry and try to tell me that's negative 2. That's not a negative 2. X is equal to negative 4 divided by 8 is a negative 1/2. Okay, that's a fraction. So I'm going to write my answer as a fraction, negative 1/2. And then I'm going to take that value and I'm going to plug it in up here. So I'm going to say y equals 2. I'm going to put in the x value that I just found. And I'm going to calculate the y value. So y equals 2 times a negative 1/2. Okay, half of 2 is 1, and it would be negative. Negative times a positive is negative. Minus 1, y equals a negative 2. I always write my answer as an ordered pair. So I'm going to say negative 1/2. Put x in the ordered pair first, and then your y value. That is your solution to that system. Okay, now we had some situations where with the graphing where we saw parallel lines, or we saw, which was a no solution, and we saw where the two lines graphed on top of each other, which was an infinite solution. Let's see what that looks like when we're solving using substitution. So if I said, okay, I've got a system that says y equals 3x plus 1, and I've got one that says 6x minus 2y equals negative 2. Okay, again with this system, and consistently in all three of these examples, I've had y by itself all the time, but I'm going to tell you that it's okay. You just need to have a variable by itself. If it's x that's by itself and it says x equals something, then you would be substituting into the second equation for the x. But again, here we have y by itself. So we're going to take all of this that y equals, and we are going to substitute it into the bottom equation in place of the y. So I'm going to say 6x minus 2, and then I'm going to replace the y with the 3x plus 1, and I still have this equals negative 2. Once I've substituted, I'm going to solve this. I'm going to distribute first. So I'm going to get 6x minus 2 equals negative 2. 6x minus 6x. Well, what happens to your x's here? 6x minus 6x is 0x. Your x's drop out. You're left with negative 2 equals negative 2. Does negative 2, is that a true statement? Does negative 2 equals negative 2? Because that's true, you would say infinite solutions. That is true. So there's going to be many solutions. Too many to count. That's an infinite solution. That's like if I were graphing that top equation. Okay, if I were to graph this equation and then graph that, they would graph right on top of each other. Okay, that's an infinite solution. Now, when you encounter the no solution, when you get done with your substitution and you get to this point, yes, your variable is going to drop out, But what you're left with, if that's not a true statement, if that says something that's not true, then your answer would be no solution rather than the infinite solution. And in graphing, that would be where you have your parallel lines. Okay, that's how solving by substitution works. And go ahead and give that worksheet a try.